So probably one of the weirdest shapes to deal with out of all of these is a sphere or a ball, if you'd rather, because it can't really be broken down into component pieces that are polygons. Or, like we took the triangular prisms and broke it down and we got rectangles and triangles. And this doesn't work like that. So this is probably the farthest from an example. I can't give you an example where we make it something else. So I'm just going to jump in and give you guys the formula. This is a calculus-based formula. So it's really easy to use, but just kind of keep that in mind that this isn't easy to come up with, but we can use it pretty easily. So the formula, if you know the radius of your sphere, the formula for the surface area of a sphere is 4 times pi times the radius squared. So I want to talk about that just for a second because it'll help us out for tomorrow. This part right here should look familiar, right? Pi r squared. So we know that pi r squared is the area of a circle. So what I'm saying is that the surface area of this ball is exactly 4 circles worth of the flat two-dimensional representation. Okay, so keep that in mind because I'll come back to that tomorrow when we start doing what's called a hemisphere. But for today, 4 times 3.14 times your radius squared. This should be probably the quickest, although it's like the most complex shape that we've done, it should be the quickest one to find the surface area of because it's just punch it in, you're done. Okay, so here we go. I'm going to go set this one up. I just want to write it out so you can see it. 4 times pi times 17 squared. Don't forget to square your radius. Whoops. I've got 3,629.8 square yards. Okay, that's it. 4 pi r squared. I'm not even going to give you the diameters on these, although I could. I think you guys are pretty good at making that adjustment now. So 4 times pi times 4 squared. Just a coincidence, those are 4s. 16. 200.96, so 201 square feet. Okay. Really straightforward. Again, like I said, this formula is somebody discovered this using calculus. I don't really have a good explanation, but basically, if you were to kind of think of it as like an apple, and you were to cut the peeling off of an apple, if an apple were like perfectly spherical, which it's not, but if you were to peel an apple, and you could put all those little pieces of peelings together to make 4 circles. Okay, give it a shot.